Okay, so calculate the largest wavelength of photon that could create this pair. This pair is referring to the muon, right, with this energy, 106 MeV, right? Now notice that we got like some answer like 105.86 or something like that. Let me look at it. 105.865 or something like that, right? Okay. Usually, the question is which one of these values should we use? Usually you go with the one that IB gives you, right? So let's go with that one. Okay. So now, basically, the largest wavelength of photon, largest wavelength means smallest energy, right? Well, the smallest energy possible is the one that can just simply create the muon-anti-muon pair, right? Okay. So that energy is going to be 2 times 106 MeV. Okay. So we're just going to create them, and then evidently they don't have any kinetic energy, right? So they, immediately hit each other and annihilate? I don't even know. Right? But this would be, of course, the minimum. You certainly couldn't do it below this, and you might need a little bit more than this, right? All right. So that is, I think that's 212 MeV, right, times 1.60 times 10 to the minus 19th, right? And this is, I'm just trying to get joules, right? So 212, remember, million is E6, right? Okay, so I'm going to go 212 E6, right, times 1.6 E minus 19. Don't forget the million, right? That's important. And I get that 212 MeV is equal to 3.392 times 10 to the minus 11th joules, which really doesn't sound like that much, not much for a baseball, but a lot for a photon, okay? So now we want to figure out what is the wavelength, right? So wavelength is hc over the energy, right? So that's going to be 6.63 times 10 to the minus 34th joule seconds times 3.00 times 10 to the 8th meters per second, right? So now we got joule meters divided by 3.392 times 10 to the minus 11th joules. So joules cancel, seconds cancel, we'll end up with meters here. So 6.63 E minus 34, okay, times 3 E8 divided by the answer I just got is 5.86 times 10 to the minus 15th meters, right? Which would be 5.86 femtometers. Now, the answer up here is, and by the IB would take either of these answers. This answer I got, I believe, by using 105.86 or something like that, right? Okay. Which would be the right thing to do because it's more precise. It's really our best guess. But IB is going to do this, and they do it, a lot, and it annoys me. Anyway, all right. Now the question on the test is the one I just took right off an IB test, and I think you guys did it. And the question is, explain why there is a threshold, and it was talking about frequency, right? So energy is HF, right? Explain that there is a frequency below which you cannot create the pair, right? And the answer to that question, the reason why there's a threshold, is that the energy of the photon can't even create the matter. It has to have at least enough energy to create the matter. It has to have enough energy to create the rest mass, as we say, okay? We have to create the matter from pure energy. And if you don't have enough energy, if you don't have this much energy, you're out of the game. You can't make these particles. You can make something more lighter, right? But you can't make those particles, right? Because you don't have enough energy. All right.